All right, so now we're going to look at the second part of L'Hopital's rule. It'll be really similar, it's just one small difference. And the only difference between this version of L'Hopital's rule and the other is I'm still trying to take the limit of this fraction, but now instead of getting 0 over 0, I'm going to get infinity over infinity. So if I get something that's infinite divided by something else that's infinite, then I can use L'Hopital's rule as well. All right, so evaluate this limit. All right, I'm evaluating it at infinity. If I try to plug in infinity, I get 3 times infinity plus 5. Well, that's just going to be infinity. 2 times infinity plus 1, that's also infinity. All right, so both of these would give me out these really big numbers, so I can use L'Hopital's rule. All right, and I get the same limit, but now I take the derivatives of these things. The derivative of 3x plus 5 is 3. The derivative of 2x plus 1 is 2. And it doesn't matter what I plug into that, I'm always going to get 3 halves. All right, so my final answer is 3 over 2. And we actually did problems like this before. You look at the highest powers of x and just get the 3 over 2 that way. But now this is kind of less rules you have to remember. Just remember L'Hopital's rule. Doing derivatives will get you to this answer. And this one, we're trying to find the limit at infinity again. Natural log of infinity. The natural log just keeps going up forever, so that's infinity. 5 times infinity is still going to be infinity. So I use L'Hopital's rule. Same limit bound. The derivative of natural log of x, these are one of the ones you should have memorized. The derivative of the natural log is 1 over x. And derivative of 5x is 5. And this, if I simplify it, becomes 1 over 5x. And now I want to try to plug in infinity again. If I plug in infinity, I'm going to get 1 over something infinite. And if I'm taking a constant and dividing it by a really big number, I'm going to get 0. And so my final answer for this one is 0. And go ahead and try this one on your own, see if you're kind of understanding the idea of L'Hopital's rule. So pause the video, try it on your own, and then I'll kind of show you the solution after that. All right, here's the worked out answer. All right, so you try to plug in infinity. Our polynomials are both going to give you infinity. So you use L'Hopital's rule, taking derivatives. Here, if you plug in infinity, you'll still get really big numbers on the top and bottom, so you have to use L'Hopital's rule again. But now there's no x's to plug into, so no matter what, you're going to get out 6 over 10, and that simplifies to 3 over 5. So L'Hopital's rule, always check when you're taking the limit of a fraction. If you get 0 over 0 or infinity over infinity, you do L'Hopital's rule, you take the derivative of the top, you take the derivative of the bottom, and then you retry your limit. All right, so that's the important rule. So now if we kind of went back to a lot of the problems we did in Unit 1, we would just be able to use L'Hopital's rule, and we would have to do a lot of algebra because now we have this more powerful tool to use derivatives. All right, so in class we're going to do a little bit of approximating practice using tangent lines like we did in the first video of this series. We're going to spend most of our time revisiting limits and doing L'Hopital's rule because that's something that's really powerful that we'll have to use a lot on the AP exam.